Hi friends, our next topic is radioactivity. It is nothing but a nuclear phenomenon in which an unstable nucleus undergoes a decay. That is referred to as radioactive decay. Now, it has many types like alpha decay, beta decay, and gamma decay. We'll discuss each of these in detail. Before that, we have to know something important about the rate of this radioactivity. In any radioactive sample, it is found that the number of nuclei undergoing the decay per unit time, that is the rate, right? It is proportional to the number of nuclei in the sample at that particular instant of time. Say if n is the number of nuclei in the sample and delta n, this many nuclei are undergoing decay in that amount of time delta t. Okay. Now what can I say? Delta n by delta t is proportional to the total number of nuclei. That's what is the statement, right? So to remove that proportionality, we'll introduce a constant, and that is called alpha, that is radioactive decay constant, or simply you can say disintegration constant. As the nuclei decays, what happens? The number of nuclei decreases, right? So my delta n is decreasing, or it is negative, I should say. So I can say that dn, which is actually giving me the rate, it is equal to the negative of delta n. Delta n is the change, or say delta n is always positive. It is the difference between the number of nuclei before this time interval and after the time interval. So delta n is always positive. Dn is the change, that is minus sign indicates the reduction of nuclei. Hope everything is clear till now. So my rate is actually given by dn by dt, which is nothing but negative of lambda n, that is lambda is radioactive decay constant or disintegration constant. What can I infer from this? I can write the same equation as dn by n is equal to minus lambda dt, right? So I want to integrate this. Since lambda is just a constant, I can put this outside. And from where should I integrate? Say t0 is my initial time to final time instant t. Let t be variable so that I want to make a formula here, and n naught be the initial number of nuclei. So let it be n here. That integration is going to give me ln n minus ln n naught is equal to minus lambda times t minus t naught, that is the time interval. Okay, the same thing can be written as ln n by n naught is equal to minus lambda t. If my t naught is 0, I am saying that my initial time is 0. I am starting with t naught is equal to 0. That is, t is nothing but the amount of time. Hence, this equation can now be written as n is equal to, or n of t, it will be nice, is equal to n naught e power minus lambda t. So this is how the number of nuclei vary with time. This is the function of n with respect to time, right? This is known as law of radioactive decay. This is important. This is about number of nuclei. What about the rate at any time instant? When we differentiate this equation with time, I'm going to get dn by dt is nothing but minus lambda n naught e power minus lambda t. Multiplying this equation with a negative sign, I can write the same thing as minus dn by dt is nothing but lambda n naught into e power minus lambda t, right? Well, what is this? Minus dn by dt is nothing but the rate. Are you getting me? So, the rate. And what is lambda n naught? It is the initial rate at time instant 0. That is what we started with, right? So, the same equation becomes this one. So, when r naught is equal to lambda n, that is the initial rate at time t naught, then this is the equation which gives the rate at any particular instant of time, or I'd rather write this as r of t as a function of. So what is the unit of this rate? It is 1 becquerel is nothing but 1 disintegration or 1 decay per second. But The commonly used unit is 1 curie, which is nothing but 3.7 into 10 power 10 decays per second, or 3.7 into 10 power 10 becquerel. Our next topic is half-life. Half-life is nothing but the time taken to half the number of nuclei. So if the initial number of nuclei were n naught, then after say time t, they become n naught by 2. The time t is known as half-life. Actually, it is given by this capital T, and it's written 1 by 2 in the subscript. So by using that formula, what can we write? My final n should be n naught by 2. That should be equal to n naught into e power minus lambda t, right? So this should be t power 1 by 2 here. Hope this equation is clear. So I can write the same equation as e power lambda t half is nothing but 2. When I take logarithm on both sides, I'm going to get lambda t 1 by 2 is nothing but ln 2. In other words, t half-life is nothing but ln 2 by lambda. So this is the equation which gives half-life. It depends only on the disintegration constant, or you better remember it this way, 0.693, which is nothing but ln 2 by lambda. Hope this is fine. And now you know what is half-life. There is something called as average life or mean life. Average life is nothing but it is the total life lived by all the nuclei. When that total life is distributed equally to all the nuclei, then the lifetime of each nuclei will be the average life. Or you better take this example, you will get an idea. Say initially there were 4 nuclei, okay, for simplicity, A, B, C, D. And say this lived for 4 seconds, and this lived for 3 seconds, this lived for 2 seconds, and this lived for 1 second. I mean, initially there were 4 nuclei. After 1 second, this got disintegrated, so 3 were left. After the second, this got disintegrated, so 2 were left, and this lived for 3 seconds. That means uh, at the end of the third disintegration, only this was left. That is how you have to understand it. So the lifetime of this one will be 1, right? But this particular nucleus has lived for 1 second, okay? But this particular nucleus has lived for 2 seconds, and this one has lived for 3 seconds. This one has lived for 4 seconds. So the total lifetime is what? Is 10. So when I divide this equally for the 4 nuclei, I'm going to get 2.5. So I can say that each nucleus has lived for average life or average lifetime of 2.5 seconds. That is how you have to get intuition for average lifetime. But actually in any practical case, there are some millions of nuclei, right? So at any second or any instant, there will be some thousands or millions of them decaying. So you have to calculate the average life by using integration. When I multiply the rate with the time interval delta t, I'm going to get the number of nuclei which are decayed in that particular time interval delta t. Hope this is clear, because the rate into time is nothing but number of nuclei. And the number of nuclei is given by what? I have this formula, right? Lambda n naught e power minus delta t is what? Is the rate, and multiplied with the delta t. I just wrote the RT in this way, and delta t is the same. Hope this is clear. These are the total number of nucleons that are decayed from t to t plus delta t. That is in this short time. Assuming that delta t tends to 0, we shall do the integration. But what does this mean? These many nuclei have been decayed in this time interval, which means that till this point, till time t, they were not decayed. Got it? So I can say that these many number of nuclei, this is these many number of nuclei had a lifetime of t. So when I multiplicate this with t, this will be the total life of all these nuclei, and I have to integrate this from from t is equal to 0 to final. Final is actually infinity, that reactions just go on, and this time should be equally distributed to all the initial nuclei, right? So that should be equal to the initial nuclei and average time period, average mean life. That is what the meaning of average life is, right? Because it means that each of the initial nucleus has lived a tau time of life, that will be equal to the net entire lifetime of all the nuclei. Hope you got clarity here. Otherwise, please feel free to rewind the video and go through this conversation once again. If you understand this equation and nothing is left, just maths is left. The same equation can be rewritten as tau, that is the average life, as lambda n naught, and this integration from 0 to infinity t e power minus lambda t dt by n naught. I just rewrote the equation in a different form, nothing really missed, and lambda 0 to infinity. This is the final integral, right? Now there are two functions of t here. Let us use by parts formula. That is, for this integral, it will get first function into integration of second function minus differentiation of first function into integration of second function, whole integration. So when I integrate this again, so I'm going to get the same equation written in this form: t power lambda t by minus lambda, and you have minus e power minus lambda t by lambda square. This is the integral, right? And limits are from 0 to infinity. Firstly, I'm going to get 0, and next I'm going to get minus 1 by lambda square. So my integral is 1 by lambda square, and putting that in that equation which I got for tau, it is lambda, and I had integral here, right? So I'll put 1 by lambda square, which is my this one solved integral. So I'm going to get 1 by lambda. Our final simplified result is that my average life is nothing but 1 by disintegration constant. Interesting, right? We did a lot of work and got simple result. Remember this equation once and for all. T half can be written as ln 2 by lambda, right? But what is lambda? I just got it to be 1 by tau. So I can write it as tau ln 2. Now let us do this problem. Half-life of uranium-238. Uranium's atomic number is 92. This is undergoing alpha decay. I'll explain you what is alpha decay in the next video. And it is given as 4.5 into 10 power 9 years. This is the half-life. Now I have to find the activity of 1 gram sample of this thing. 1 gram. Okay. Now 238 grams of this uranium 238 contains Avogadro number of atoms and hence nuclei. Hope this is clear. So 1 gram should contain how many? Avogadro number, which is 6.023 into 10 power 23 by 238, right? These many number of nuclei should be present initially. Just calculate it, you will get it to be 2.53 into 10 power 21 atoms or nuclei. Well, I got the initial number of nuclei. Rate. What is rate? Rate is nothing but lambda times n. Lambda can be written as ln 2, 0.693 by half-life, because half-life is nothing but ln 2 by lambda, right? And initial number of nuclei, I know it from here, it is 2.53 into 10 power 21, and half-life is given as 4.5 into 10 power 9 years. Don't get confused there. You have to put the time in terms of seconds here. So when you convert into seconds, it will be 4.5 into 10 power 9 into 365 into 24 into 3600. That will be 1.42 into 10 power 17 seconds. Put this value for t half here. So it's going to be 1.23 into 10 power 4 disintegrations per second or becquerel. In the next video, I'll tell you what is alpha decay, beta decay, and gamma decay. And that's it for now. Keep watching.